Have you ever really thought about the odds, the actual numbers behind a coin flip, or a weather forecast, or maybe even a lottery ticket? Well, today, we're going to pull back the curtain on the mathematics of chance. We're going to learn how to take all that uncertainty and turn it into a number we can actually work with.
I mean, think about it. Every single day, we are surrounded by unknowns. Are you going to win the big prize? Is it actually going to rain on your picnic? Are you going to ace that test? It feels like we're constantly just guessing. But it turns out there's this incredibly powerful tool that helps us navigate all of it.
And that tool, it's called probability. At its heart, it's a really simple, beautiful idea. It's just a way of putting a number on how likely something is to happen. If the number is 0, forget about it. It's impossible. If it's a 1, it is a stone-cold certainty. Everything else in our lives happens somewhere in between.
Okay, so let's get into it. Here's our game plan. We're going to start with the core formula, the engine of it all. Then we'll look at what happens when events are connected. After that, we'll get into how to update your beliefs with new info. And finally, we'll see where this stuff pops up in your world every single day.
All right, let's start with the absolute foundation of probability. This is the simple math that powers everything else we're going to talk about today.
So, at its core, probability just boils down to this one simple fraction. It's the number of ways your desired outcome can happen, divided by the total number of things that could possibly happen. Seriously, that's it. That's the secret sauce.
And to use this formula, we only need to know two little things. The first is the sample space, which is just a fancy way of saying a list of every single thing that could happen. The second is the event, and that's just the specific thing you're actually interested in.
So let's see how this works with a really clear example from our source material. Picture this. A bed has 6 pillows, all different colors. And we want to know, what are the odds of just reaching in and grabbing a yellow one without looking?
We just have to follow 3 super simple steps. First, what's our event? Well, we want a yellow pillow, and there are 2 of those. Second, what's our sample space? That's all the pillows. There are 6 of them. And finally, we just do the math. And boom, there's our answer. 2 divided by 6 simplifies down to 1/3. You have a 1 in 3 shot of picking a yellow pillow. See? Simple, right?
Okay, but now things start to get a little more interesting. What happens when our choices aren't totally separate? When one thing happening can actually change the odds for what happens next?
I mean, this is a question that comes up all the time in real life, right? Think about drawing cards from a deck or picking players for a team. The first choice you make changes the whole landscape for the second choice. And this is exactly where the idea of conditional probability comes in.
Conditional probability. It sounds kind of formal, but it's just a way of asking, what's the chance of event A happening, given that we already know for a fact that event B happened? That little vertical line there just means given. Now check out this card example. It's perfect. The chance of pulling a red card first is exactly 50-50, 26 out of 52. But once you do that, the deck has changed. Now there are only 25 red cards left and only 51 total cards. The sample space shrank. So the probability for the second draw actually drops just a little to about 49%. The second event depended on the first.
Okay, now we get to the part where probability becomes a kind of superpower. We're going to look at a way to actually work backwards, to use new evidence to intelligently update what we thought we knew.
This whole concept is known as Bayes' theorem, and it's a huge deal. You can think of it as a mathematical formula for learning from experience.
It's almost like a magic trick, for real. If you know the probability of seeing some evidence if a situation is true, Bayes' theorem lets you flip that whole question around. It lets you find the probability that the situation is true given the evidence you just saw. So the process is pretty straightforward. You start with what's called a prior probability. That's your best guess before you get new information. Maybe you think there's a 10% chance your favorite team wins the championship. Then, after you get new info, like say they sign a superstar player, you can calculate a posterior probability, your new updated belief. You've literally learned and adjusted your odds.
So here's a simple way to keep these 2 ideas straight in your head. Conditional probability looks forward. It asks, if this happens, what's the chance of that happening next? Bayes' theorem looks backward. It says, okay, this new piece of evidence just showed up. How should that change my original belief?
So why does any of this math matter? I mean, this is all fascinating, but what's the point? Well, it matters because these ideas aren't just for textbooks. They are quietly running in the background of your life every single day. For starters, your email inbox is a great example. It's using Bayes' theorem right now.
It calculates the probability that an email is spam based on the words inside it, and it updates its beliefs every single time you mark something as junk.
And then there's medicine, where this is absolutely critical. It helps doctors figure out the true probability that you actually have a disease given a positive test result. It does that by factoring in not just your test, but also the test's accuracy and how rare the disease is in the first place.
And of course, this is the engine behind pretty much all modern AI. From your phone recognizing your voice to the stock market predicting trends, probability is how machines learn to make sense of a chaotic world and make really intelligent guesses.
Okay, so let's bring it all home. What are the big ideas to take away from all this? First, probability is our best tool for putting a number on uncertainty. Second, the basic formula is just a simple fraction. Third, conditional probability is how we handle events that are linked together. And maybe most importantly, Bayes' theorem gives us a smart way to update our beliefs when we learn something new.
In the end, probability isn't just something that lives in a math book. It's a lens. It's a new way of looking at the world, a way to question your own assumptions and to think systematically about how certain or uncertain you really are about, well, everything.